Hi everyone, today we're going to be talking about how to create a line of best fit for real-world data and how to make the scatter plots on a calculator. Now, one thing to realize is that real-world data very rarely creates a perfect line of dots when you graph the data points. Now, we are specifically using data that is what we call bivariate, data that has two variables attached to it that are related to each other. For instance, what we're doing in our example is year with mortality rate. And those are linked because for a given year, you can find out what the mortality rate was. And I'm sorry it's such a depressing example, but that's what our book had. Now, when you create a scatter plot, you have to remember that the x-axis is the independent variable, or the x value, and the y-axis is the dependent variable. It depends on the other one. Now, we can create a line that would model what's going on with the data, and we call that line a regression line, okay? Or a linear model if we're doing a linear model, if we're doing a straight line as opposed to a quadratic line or a cubic line or something like that. So let's take a look at an example, and hopefully I can show you how to do this on your calculator. So our example says the table gives the infant mortality rate for the period from 1950 to 2000. The rate is the number of infants who died before reaching their first birthday out of every 1,000 live births. Part A says to find the regression line for the infant mortality data. Part B says graph the regression line on a scatter plot. And Part C says to use the regression line to estimate the infant mortality rates in 1995 and 2006. And they've given us our data in this beautiful table down here. Okay, so the first thing you want to do on your calculator is enter the data into the stat menu. So stat is this button right here. You just press stat. And we want to edit, which means that we're going to enter some data. So you hit enter on that. Now list 1 needs to be the independent variable and list 2 is dependent. And the date is going to be independent because if I give you a date, you can give me a rate. So you just start typing in 1950, enter, 1960, enter. And I'm going to do this while you're not looking so you don't have to sit there and watch me enter. So I have all of those values listed in my list 1. So now I'm going to hit the arrow key to list 2, and I want to make sure that list is cleared. If you do have data in a list, if you hit the up arrow and hit the clear button and hit enter, it will clear the list. Do not hit the delete button that deletes the list. Don't delete a list. Hit the clear button because you want to clear the data that's there. Now in list 2, all I have to do is enter these numbers. So 29.2. Enter, 26.0, enter, and again, I'm going to enter this while you're not looking. Okay, so you'll notice that all of my data is entered here, and it looks like I made a mistake on 1999. I missed a 9. Okay, it's always good to look over your data, make sure it does actually match what was in your table. And one other thing to check is to make sure that these bottom lines line up because it's supposed to be paired data. If they don't line up, that means you missed a number somewhere or you duplicated a number somewhere. So double check that everything matches your table. Once you're done with that, you're going to hit second and mode to quit out of this screen. So you hit second and mode to quit. And then if you wanted the linear model, which is what they're asking for in part A, you're going to hit the stat button again. You're going to scroll right to calc, which is calculate, because you want the calculator to find something for you. And number 4 is a linear regression. Now 5 is a quadratic, 6 is a cubic, 7 is a quartic, and there are a bunch of other ones in here that we're going to talk about later this year. But we're only doing linear regressions right now, so we're doing number 4. So you can press the number 4, or you can hit the down arrow till you get to 4 and then hit enter. Okay, now if you have an older operating system, it won't bring this menu up. Please talk to me about how to do it on that calculator. But you'll notice that here it's asking me, is the X list 1? If it is, I can just leave that. If it's not, notice how we have blue list names above these numbers. that means you can hit the second button and that list name, and it will change your name here. So like if I had list 4, I can tell it list 4, and there it is. Now I don't want list 4, I want list 1. So there it is. Here it's asking if the Y list is list 2, which it is. And now if you're going to be doing more than just finding the equation, if you want to see the scatter plot, or if you want to see this line on a scatter plot, we want to do store regression equation. Okay, so to do that, there are 2 ways to get the Y1 value in here. The first one, the easier one, is if you hit alpha and F4, okay, or alpha and trace. Number 1 is Y1, and that's where we want to put it. Okay, if you don't do that, you can hit vars for variables. You can scroll to Y variables, hit function, and Y1, and it will be there. Okay, so the easier one is alpha and trace, but you can do it the other way and it would still work. Okay, and I think that's what's on the page of directions I gave you, because I didn't know about alpha and trace when I wrote that page. Okay, so we're just going to go down and calculate it now. And you'll notice what your calculator brings up. They give you y equals ax plus b. They give you an a number and a b number. This is your actual line. So over here, I'm going to type y equals negative 0.4405, and I always round to quite a few decimal places because you never know how accurate you need your answer to be. Okay, so that is my regression line. Now, I need to show you something else, because in your book, it's going to talk about a correlation coefficient and whether it was a good model. Now, we did not get our correlation coefficient up here because I did not turn on diagnostic mode on this calculator. So I'll show you how to do that, because yours might be off too. If you hit second and 0, it will bring up the catalog. And we want diagnostic mode, which is a D. So I'm going to hit this button that has a D over it, x negative 1. That will take me down to the Ds. By the way, this is a list of all of the possible functions that your calculator can do. Okay, and I hit down until I get to diagnostic on, which I hit it a few too many times. I forget there's lag here. There it is, diagnostic on. You hit enter one more time, and it will turn it on. Okay, now I want to run that regression again, so I'm just going to do this. Second and enter will bring up previous things that I've asked it to do. So I want the linear regression again. Okay, and now you'll notice the difference. There's an r squared and an r. This r value is what we want. This is what we call a correlation coefficient. And when a correlation coefficient is close to -1, or when it's close to +1, that means that it's a very good correlation. So this is a very good correlation. It's almost -1. It's negative 0.9815. So that is a very good correlation coefficient. That means my points are very, very close to the line of best fit. Okay, so now for part B, graph the regression line on a scatter plot. I'm just going to go into my y equals menu. I want to make sure that my line ended up here, which it did. And now I need to turn on my plot. Now, you need to be careful about doing this, because if a plot is on and you're not doing something with a scatter plot, it will mess up your other graphing. So to turn a plot on or off, you hit second and y equals, which takes you into the stat plot menu. And I want to turn on plot 1, so I'm going to hit enter. Now I just have to hit enter on. The type is shown as a scatter plot. X list is list 1, Y list is list 2, and I have this mark chosen, but you can pick any one that you want. And now I just have to tell it the zoom settings. So if you do zoom and stat, which is number 9 here, okay, it will show you your scatter plot along with the line of best fit. Notice how that line goes through 1, 2, 3 of these dots, and the other 3 dots are really, really close to it. So that means that this is a great approximation. Now the line does not need to go through any of the dots, but it will go through what I call the center of the pack. Okay, it will be like through the middle of where all of the dots are. Now, the last thing we're asked to do is to use the regression line to estimate the infant mortality rates in 1995 and 2006. Okay, 1995 will be a very good estimate because it's within this data and we had a good correlation coefficient, but 2006 is outside of this data range. It's pretty close, so it'll probably be okay, but it's not going to be perfect. Okay, now part B, our graph, you do not have to copy this onto your homework. I am just going to trust that you did it. So you never have to copy this onto your homework. If you want, you can send me a digital picture of it. That's up to you. But that's okay. You don't have to. So I'm going to quit out of this and I'm going to do part C. For part C, I'm going to evaluate. Now, my function is in Y1 and I put it there. So I'm going to evaluate Y1 for this number. So I'm just going to hit alpha and F4, and I'm going to bring up Y1. Now to evaluate for a data point, I have to put parentheses and then 1995 parentheses. This means I'm going to take the numbers 1995 and put it into the function for X, because remember, X was year. Okay, and I just hit enter. So the mortality rate for 1995 was probably close to 9.17 or so. Now to get 2006, a shortcut would do second enter, and that will bring that up again. And I just have to change this number to 2006. Okay, and hit enter. And 4.3 or so. Okay, so those are my values for C. And all you have to do is tell me in 1995 it was like 9.2, and in 2006 it was 4.3. And you just write that on your paper, and then you'd be done with the question. So that's it for this video. Let me know if you have any questions. I'm also going to upload a PDF of these instructions kind of typed out.